Leetcode 790 Domino and Tromino tiling. So in this problem we are given one domino and one Tromino tile. We have to construct a 2x n board using this domino and Tromino tiles. So we have to return the number of ways we can construct this 2x n board. Since the answer could be very large, we have to return it in modulo 10 power 9 plus 7. Here if we see that in example n equals to 3, we see the output is 5. The way we have clubbed this domino is in the first row, and the way we have clubbed this domino is in the second row. We'll also look at the constraint, which is n is greater than equals to 1 and less than 1000. Let's try to analyze how we can club this and create for different inputs. So for the first input, our n is 1. We can take only one domino which is of this form. So our answer for this becomes 1. So we'll store this answer for our future reference. We'll store this answer in dp of 1, which is 1. So now we will try to construct for n equals to 2. We have to create a 2x2 domino. For creating a 2x2 domino, the two possible ways are depicted here, 1 and 2. Here we will mark the next one as L2 and we'll save it for future reference. We'll also mark the result for dp of 2. We have the value as 2. Now we will try to construct 2x3 using the above 2. How we can construct that is, firstly, for 2x3, what we will consider? We will consider this 2x2 dominoes which we have already created, two dominoes, and we will multiply it with L1, which is the one way which we have stored for future reference. So we will take this 2x2 and we will club with L1. We will get 2x3 domino. This is one way of creating this. The other way is, what we can do, we can take this 2x1 domino and we can club L2. Here we can see that L2 is this one which we have stored for future reference. We can club this, we get one way error also. So here we get two ways, here we get one ways. Now are we missing something in this? Because in answer we have got 5. We are missing this two cases where we have made using a Tromino. So these two cases were missed, which we will mark it as L3 and it is 2. Now we will try to construct a 2x4 case where n is equals to 4. What we will do is, firstly we will take this 2x3 dominoes. What we have constructed this 5 2x3 dominoes and we will multiply it with the L1, which is 2x1, which will give us a 2x4 domino. How we will do that? We will see here, this is 2x3, this is 2x3, this is 2x3, this is 2x3, this is 2x3. These we have got from our previous 2x3 5 results. What we have done, we have multiplied with the L1. L1 is this, so we get these 5 arrangements. We'll mark it here. Now what we will see, what other ways we can take this 2x2 and multiply with L2. The 2x2 domino are there of two types, this one and this one. So we have taken this one and this one. What we are multiplying with is L2. L2 here we have stored this. So we will try to multiply with L2. So we will get more ways, which is these two. So by doing this we are getting two ways. Now the other option is, we will take 2x1 domino, which is this one and this one, and we will multiply with L3, which we have stored in our previous stage. This one is L3, which we got earlier. So we will multiply it with this L3 and we will get this arrangement. These are also 2. Now if we look at this all cases, we are getting 5 here, 5 here, we are getting 2 here, then 2 here. Are we missing something? Yes, we are missing a case where we can arrange this like this. And also we can invert it and we can get this figure. So we got these two figures. So we will mark it as L4 and its value is also 2. So now we will try to construct for n equals to 5. Here we can now observe one sequence that for constructing 2 cross 4 we required this 3 dp of 3, which is 2 cross 3 into L1. L1 is nothing but 1. For constructing we required this dp of 2 into L2. L2 is nothing but 1. For this also we required dp of 1 into L3. L3 is nothing but what we got from the previous result, which is 2. So we can similarly construct this 2 cross 5 matrix using this formula. We will require the dp of 4 into L1. We'll multiply with L1, so this will give us 2 cross 5. Now we know L1 equals to 1 and L2 equals to 1 as we have saved it earlier. Here L1 is 1, L2 is 1. Here L3 we got 2 cases. For L4 also we got 2 cases. So we have marked dp of 3. We have stored the dp of 3 earlier. We will multiply with L2 and we will get this as the result. Then we will multiply this dp of 2, means 2 cross 2 domino, with L3. We will get 2 cross 5, which is 2 into 2, 4. Now similarly we do for dp of 1 into L4. We get this as the result. Here also we will be missing a case where we will be having 2 as the answer, which will be the L5. So we can notice one thing here is we are getting an extra case of two dominoes every time. So these these can be stored like this: 1 into 2, where 1 is nothing. If we observe the sequence, it is 4, then 3, then 2, then 1. Then we can mark this as dp of 0. What is this? This is 2, which is nothing but L5. Here we can see here L4 is also 2, L3 is also 2. Only L1 and L2 are 1, remaining all others are 2. Now similarly, if we try to construct 2 cross 6, what we will get is we will take the dp of 5, which is 2 cross 5 domino, and we will multiply with L1. So then this dp of 5 we have stored earlier. Now we'll take dp of 4, multiply with L2. Remember that L1 and L2 are 1, remaining or L are 2 only. So we will do for 3 also. 3 dp of 3, multiply it with 3, we will get the 6. Then dp of 2, this 4 and 2 will multiply and we will get the dp of 2 cross 6 domino. Now for this 2, what we will do, also we have this case as dp of 1, we will multiply with L5. Now for this we will write this as 1 into 2, which is nothing but dp of 0 into L6. So we observed this one formula here, which is nothing but this: dp of 6 is dp of 5 into L1 plus dp of 4 into L2, dp of 3 into L3, dp of 2 into L4, dp of 1 into L5 into plus 2. So these two could be written as dp of 0 into L6, where L6 is 2 and dp of 0 is 1, 1 into 2. So we can observe here that if n is less than 3, that is L1 and L2, we are getting as 1. For remaining others, L3, 4, 5, 6 and all, and greater than equal to 3, we are getting as 2. So we can write this formula as this dp of 6 is equal to, similarly we try to write this formula, dp of 5 into L1, 4 into L2, 3 into L3, 2 into L4, 1 into L5. So now for dp of 6, what we try to do is we try to write a generic one. For dp of n, what we will doing is dp of n minus 1 would be multiplied by L1, dp of n minus 2 will be multiplied by L2. This L1 and L2 are 1, so we can write only n dp of n minus 1 plus dp of n minus 2, plus the remaining others will be multiplied with L3, the L3, L4, all others are 2, so we can take 2 common and we will add this from I equals to 0 to n minus 3, which is dp of I. So if we write this whole formula, we will get this like this: dp of n equals to dp of n minus 1 plus dp of n minus 2 plus 2 into dp of n minus 3. We are taking out this n minus 3, since it is 2 times multiplied, we are taking out this dp of n minus 3 and we are making this summation from 0 to n minus 4. We have taken out this to simplify this equation. If we look at this again, we will take this dp of n equals to dp of n minus 1 plus dp of n minus 2 plus n minus 3 plus n minus 3. These two we have segregated here as two parts. What we will do is we will take this 2 and 3 and we will put it here with this. We'll club it with this. The remaining n minus 1 and n minus 3 we will write it here. So here we get that dp of n minus 2 plus n minus 3 plus 2 into summation of I equals to 0 and minus 4 dp of I. If we observe carefully, it is nothing but multiplied by 1 multiplied by 1 and 2 into dp of I equals to 0 to n minus 4. So this is nothing but dp of n minus 1. So we will do this as n minus 1, and these two we have copied as it is. So if we simplify this, our formula becomes, we will add these two and 2 into dp of n minus 1, and this is dp of n minus 3. So our formula becomes this: dp of n equals to 2 into dp of n minus 1 plus dp of n minus 3. This is our complete formula. It is an order of n solution. To simplify this, to write this, we will just use a for loop and we'll iterate through this and we'll construct from bottom to top. Let's see the solution. The solution is here, as we have for 0 and 1 we are returning 1 as the output, and for the others what we are doing, we are taking this range, since we have to return it in a modulo, so we are taking this range. We can do it using two approaches. One, we can use the order of n as a space complexity, or order of 3 as a order of 1 as a space complexity. We are using here order of 1 since the only dependent on I is I minus 1 and I minus 3. So we can reuse the variable which we assign. So we will construct a 3 array and we will assign 0 as 1, 1 as 1 and 2 as 2, which is our base cases. Now from 3 we will iterate till 1 till n, then we will mark this dp with 2 into dp of I minus 1 mod range plus dp of I minus 3 mod range. This range are there for modulo. We will return then dp of n mod 3, which will be our answer. Let's see the this is an accepted solution. So this was the overall solution of Domino Tromino. Thank you.